The first step is to select the residues to mutate, in this case, the ones in the binding site. Choosing the Calculate Mutation Energy of Binding protocol, we first select for this protocol what we want to treat as the ligand chain. And since we'll be doing alanine scanning, we'll choose the single mutations. All the residues that have been selected are shown in the list. Selecting these residues now, I can define that each of them is to be mutated to alanine. I could choose multiple other residues to add to the list, and again, each would be treated as a single point mutation. Finally, in this case, I'll run this on multiple processors. The alanine scan predicts that 3 residues are more destabilizing than the others. In other words, tryptophan 50, tyrosine 102, and tryptophan 108. The 3 hotspot residues, in this case above 2 kcals per mole, with the binding site residues that are not hotspots, we were able to now run a saturation scan. Once again, we'll define the ligand. We'll still be doing single point mutations. And now, for the remaining list of residues, we'll be applying a subset, or indeed all possible amino acids for single point mutations. On these calculations, it is possible to run an additional scan for each residue to determine the pH dependence or the temperature dependence of the calculation. In this case, we'll run it on, again, a number of available processors. When the saturation scan job completes, the report will contain the 5 most stabilizing and the 5 most destabilizing mutations that were made. Also, if the Calculate Change versus pH is turned on, we'll see a pH plot for mutation energy in kcals per mole versus pH for each of the transformations. In addition, there are several tables, one covering the change as a function of pH, and then one focusing at pH 7.4. We'll open that table, and now inspecting this table we can see the actual energies of transformation for each of the mutations listed. This table can be sorted to easily identify the top residues, the top transformations that were present.